Hey friends, welcome back to the channel. So today I am going to explain chemistry section of IMAT syllabus. This is our ongoing masterclasses series of IMAT syllabus. First I have already explained biology of IMAT syllabus, and now today we are going to explain and learn IMAT chemistry section. So why the basic purpose of making this class is just because I already explained in biology class that IMAT syllabus that Italian Ministry publishes is very general. They generally mention the chapter name. So what I have done is that I made table of contents in a very easy manner, and then additionally I explained topics with every chapter, like what is under this chapter. All those topics are mentioned with explanation from my own notes. So let's go to screen and see what I have cooked today for chemistry section. So this is our chemistry specifications for IMAT 2024 and 2025 masterclass, but this is I have written here part 2. So this is just because I have published biology class as part 1, and now this is part 2, and we have got the part 3 of physics that we are going to publish soon. So now let's go to straightforward to table of contents. So what I have did in chemistry section in chemistry class is that I divided whole chemistry syllabus in 2 parts, in 2 categories, like first inorganic chemistry and then organic chemistry. This is basically what IMAT syllabus is consist of. So inorganic chemistry, in inorganic chemistry we have got total 10 chapters. So now the first chapter is matter. Under matter we have got solid, liquid and gases, then atom, then periodic table, then chemical bonding. So this IMAT in this inorganic chemistry section is just like, first we have got matter. Matter consists of atoms. Then we are going deep into atom, studying the periodic properties of atom, like atomic structure, and then ionization energy, then trends, all that periodic table. We are going to learn all the atoms that exist in this universe. And then we have got chemical bonding, like atoms bond with each other, with what type of bonding we are going to learn that. And then acid and bases, what are acids, what are bases, what are the buffer solutions. I have mentioned each and everything. Let me go through quickly what we have cooked this. So this is all we going to learn in this class. So just let's go back to our content section. So here is our chemistry content system. This is our inorganic chemistry table of contents. After acid and bases we have got stoichiometry. Then after stoichiometry we have solutions and chemical equilibrium, and then reaction kinetics and electrochemistry. Although electrochemistry is not included in IMAT 2023 syllabus, but I have mentioned because in electrochemistry we are going to do some chapters, some topics that IMAT syllabus contains, like oxidation number and reduction, oxidizing agent, reducing agent, and balancing chemical equations. So we are going to learn that. So that's why I mentioned it. Then we have got our second category is organic chemistry. So in organic chemistry we have got our, first of all, introduction, what are organic compounds, like functional group, basic introduction of organic compounds. Then we have got hydrocarbons. So in hydrocarbons we are going to learn alkanes, alkenes and all that stuff. Then we have alcohols and phenols, then aldehyde and ketone, and next we have carboxylic acid. Although carboxylic acid contains its derivatives like ester. Then we have got acidamide, acid anhydride, all the stuff. So and then cyanohydrine, cyanohydrine, that is also the derivative of carboxylic acid. And in last we have alkyl halide. So we are going to do each and everything. So just stay with me, grab your hot drink, and let's begin this master class. So first of all, who I am, or who am I? So I am Sami. I appeared in IMAT 2023 and got 46.2 marks. Although I could not get in med school, but nowadays I'm trying to make legit videos on IMAT stuff, and this is my Instagram handle, where you can, if you have any query, you can surely ask me anything. And then now move on to our first chapter, that is matter. In inorganic chemistry we have got first chapter, that is matter. So we all know that matter has got four basic there are four types of matter, like four states of matter. First is gases, solid, liquid, and then plasma. Plasma is although is not included in our syllabus, but if you want to learn, go ahead and just learn properties. We just discuss the properties of plasma, but now today we have got to cover solid, liquid, and gases in very detail. So matter is just solid, liquid. In solid we have got main properties and then types. Types are amorphous solid and crystalline solids. And then next we have liquid, their main properties and bonding. Although the bonding is I made separate chapter, the chemical bonding. We are going to unleash all the chemical bondings in chemical bonding chapter, but I mentioned here because you can liquid also contains bonding like hydrogen bonding, water in FON, the most electronegative element. If it is between, it gets hydrogen bonding. And then we have got gases. So gases is important, very important. Like in gases we have got to cover main properties, and then in gases in main properties the best explanation was given by kinetic molecular theory, so we need to cover that thing. But then we have got laws of gases. There are four laws: Boyle's law, Charles law, and Avogadro's law. Sorry, three laws: Boyle's law, Charles law, and Avogadro's law. We are going to learn that, and I did not mention here the general gas equation, that I did not mention here, ideal gas equation. We need to cover that too. I added my notes pictures. I'm going to explain, but I did not mention the in just heading or in our introduction. So now what in matter we have got to cover introduction to states of matter, then properties of gases, kinetic molecular theory. This is the theory that explains best properties of gases. Then we have gas laws: Boyle's law, Charles law, Avogadro's law. And Avogadro's law, combining these law makes ideal gas law, that is PV is equal to nRT. We are going to cover that. Real gases and deviation from ideal, what are real gases and what are unreal gases, not unreal, but just real gases and ideal gases. Unreal, no, that's not a thing. Unreal, it's ideal and real. Okay, then we have properties of liquids. Like this is all about gases. And then we have got liquids. In liquids we have got intermolecular forces. Intermolecular forces are of like hydrogen bonding, like London dispersion forces, dipole induced dipole. So we are going to cover each and everything, just stay with me. Then we have properties of solids, types of solids, crystalline, amorphous. Then we have properties of solids: melting, freezing, evaporation, vaporization, boiling point, condensation, sublimation, and deposition. All the stuff, physics, just neglect that thing. Although this is when we study graphs, there are critical points and critical temperature, all the stuff, so that's why I have mentioned here. But now let's move on to gases, our first state of matter. So I have generally explained here what is matter, like mass and occupy space. But today I'm not going to explain deeply. The class gets very lengthy. We have got 54 slides for this chemistry masterclass, so I'm not going to focus on each and everything. That will make class so much lengthy. Just like the biology one, I just in start I was very explanatory. In first 40 minutes I explained I explained 1-2 chapters, but in next 40 minutes I explain rest of the bio. So I'm not going to do that thing today, but I will be like moderately explaining each and everything. So first, in gas we have got properties like shape, non-definite volume, IMF is intermolecular forces. Then there is diffusion and distance, compressibility, all that stuff. You know that these things are basic, and I bet you I can just say that IMAT exam is going to ask questions from these basic things, and at the time of exam you will not remember because you didn't focus at the time of your preparation so much deeply. You were saying that this is so much easy, this is very basic. IMAT is not going to judge that thing, cannot assess that, but IMAT will judge you, so be careful. And then we have got motion, density. So this is the kinetic molecular theory. Kinetic molecular theory explains gas are tiny particles that are made up of molecules, and then collision that occurs between gas molecule is elastic collision. What is elastic collision? We are going to I'm going to explain in physics section in very detail, because in IMAT 2023 there was a question from elastic collision in one dimension. There was like 1.5 marks question that I did not solve. Just kidding, I did not remember the formula. So we are going to uncover in physics class. So then we have got pressure. Just to get a reminder for physics class, just follow me on Instagram. I announce each and everything there. So and then we have got pressure, like when gases exert pressure when they collide with each other, or when they are in container, when they collide with the walls of container, they exert pressure. So this is what I have written here. This is the collision. The more collision, the more will be pressure. That's simple. And this is the base. This is a very tricky point, and I think BMAT question has asked question. BMAT has got one question from previous exam papers about this, like kinetic energy average depends only on temperature. Kinetic energy total depends on temperature. This is not written, this is not visible. I just made this round thing, corner rounding disappear, that hidden that thing. So here was written kinetic energy total also depends on number of moles, and I have written here, you can see my notes. So that was thing, the kinetic molecular theory explained that thing, and this was in BMAT. I think IMAT or BMAT, one was the paper where it was in. So here I have written some questions like at STP maximum kinetic energy, which compound or what number of moles will have high kinetic energy total at standard temperature and pressure, STP. So 1 mole of H2, I have marked the right option because I explained that kinetic energy total depends on temperature as well as number of moles. So now number of moles are higher of this C option, so I choose the C option, right? And then this is the similar question. We have got this question, this kinetic equation, then root mean square. Here many questions can be solved from this equation, like temperature is directly inversely proportional to molar mass. Molar mass is inversely proportional to density. So these combination can solve many problems, many questions. Then we have got some question here from above these equations. Gas laws are ideal gases. These laws are obeyed by only ideal gases. Real gases do not obey these laws. Boyle's law, Charles' law, and Avogadro's law. So what is Boyle's law? Volume is inversely proportional to pressure at constant number of moles, and temperature is Boyle's law. So Boyle's law, here is the equation, just P on here, P is dividing here on the left side, it will be multiplying. So PV is equal to K is the constant, depends on number. So this is the question. K only depends on number of moles and temperature. So this is the thing. And now for initial volume and pressure, and for final volume and pressure. So this is the law. PV V1, P initial volume, P initial or volume initial equal to P final and P V final. Sorry, different value for this. This is the tricky part of laws, gas laws. We are going to deal with this situation in Charles law. So now this is the question that can be made here is gas V1. So we have got one gas, its initial volume is 1 decimeter cube and its initial pressure is 2 atm and its final pressure is 6 atm. What would be its final volume? We are going to use this relation. So now let's put this relation, but this can be solved easily by using this equation. So how? Like, just compare that these are inversely proportional to each other. So if we given we need to find V2, but what is P2? Like 6 atm. So 6 atm, these are inversely proportional to each other. So it means if it is 6 times, then it means that it will be half of it. These are inversely proportional to each other, so volume will be will decrease 3 times or P. So just like if you put this one here, this is the short rate. If you solve in this way, you will get 3, and if it was 6 and you will get 3, that can be. This is very easy thing. I know I cannot explain in a way that I need to be, like I cannot explain very smoothly, but this is how you can solve these types of problems. So this was Boyle's law. Then we have got the graph of Boyle's law here, some MCQs from, and then we have got Charles law. Charles law, what is Charles law? Volume is directly proportional to temperature at constant number of moles and pressure. These images are very blurry, I can understand. So we have got the relation here, and then we have got the absolute zero formula here. V at some temperature equal to V0 V1 plus temperature at in centigrade divided by 273. So this is how these are all the problems that I solved. These are very good. I just memorized these, and that's why I had high marks in chemistry in my high school and as well as in my IMAT exam. Yeah. So these are some more questions that I made here, and then we have Avogadro's law. What is Avogadro's law? Volume is directly proportional to number of moles at constant pressure and temperature. So now next we have ideal gas equation. Now combine those three laws, like what this is the Boyle's law, this is the Charles law, this is the Avogadro's law. Combine these and you will get Pp is equal to nRT. This is the these are some 3 questions that can be made from here, like if initial volume is half of final volume, what will be final pressure or all the stuff. So you can just just number of moles are always constant, number of moles and Rydberg constant. So this will be constant. These both will be constant. So just divide temperature over here, and you will get P1 V1 divided by T1 is equal to P2 V2 divided by T2. This is what I have written here. So you can solve all these problems with this formula. And then some applications of PV is equal to nRT, ideal gas. And these are the units of R. What is the unit in atm? So this is the at standard STP. At STP, its unit is atm decimeter cube mole inverse per Kelvin inverse. In SI unit, we have got 8.314 Newton meter mole per Kelvin. And in joules, 8.3 actually Newton meter is equal to joule. P Newton meter is equal to joule. Yeah, Pascal pressure equation. P is equal to F by A. Just make relation. That is a simple thing. And we have written in calories too. Now after this thing, we have got ideal gas. So this is the ideal gas. versus non-ideal gas, or ideal gas versus real gas. So what is ideal gas? Follows gas laws at all temperature, and pressure follows gas laws under certain conditions. So I mentioned earlier that real gases does not follow ideal gases, but they do follow in certain condition. What is the condition? That low temperature, at low temperature and very high pressure. I have written a graph here. So here is the low pressure, and then pressure gradually increases, and here becomes the real gas. So the more, these are the ideal gases, and these are the more deviation will make non-real gases. So I have written all that stuff here. Compressibility factor is equal to Z is equal to 1. Compressibility factor does not is equal to 1 in case of real gases. PV does not is equal to nRT, but in real ideal gases PV is equal to nRT. That's why these are ideal gases. So this is the compressibility factor. I made some diagrams here related to it. I think this does not make sense. No, these are the gases like exerting pressure on the walls of container, colliding with walls of container. So I just written gases, the chapter of gases here. My notes do contain the solids and liquids in very detail. I mentioned some the bonding, the forces, intermolecular forces. I have took the pictures in chemical bonding section. I have added so much notes in my next chapters, but today I'm not explaining each and everything in very detail. You would have realized that if you have watched my previous biology class. So now next, after matter, we have atom. So now matter is consist of atoms. So now we are going to just diving into atom. So in atom, what we need to actually study in IMAT, if we are preparing for IMAT. So first of all, history. What are the theories about atom model, like Niels Bohr theory, Rutherford's atomic model. So these are very interesting. I like them. I like these models very much. I remember each and everything of all those models. So then we have got Bohr model of hydrogen atom that explains atom in very detail. So you need to learn that. Then we have subatomic particles. What is electron, proton, neutron? These are the basic things. Every student, if you are preparing for IMAT, then you would surely know what are these things. These are very basic things. So after subatomic particles, we need to know what is atomic mass, what is molar mass. We are going to deal with all these things in stoichiometry too. But for now, what is molar mass, what is atomic mass, how to find molar mass, and then we have got quantum numbers. So quantum numbers are very important. I think I did not took pictures of my notes. Yeah, I did not take. So in quantum numbers, we have got types of quantum number, like principal quantum number, then azimuthal quantum number, and then azimuthal quantum number, magnetic quantum number, and then spin quantum number. So these are all the 4 quantum numbers that we need to understand in order to solve any problem related to it. So like how to calculate number of electrons in last subshell or last shell of fluorine atom. I have written each and everything in my notes. So these are very like easy. If you understand them, these become very easy. So in atom, we need to know the atomic structure, nucleus and electrons, then subatomic particles, then atomic number and mass number, isotopes and radioactivity. Isotopes are very important. So you need to know that. And so this is the question, that what is the this is the question that like IMAT has asked 2 or 3 times, multiple times. What is the like in isotopes? What is constant? Atomic number, mass number, number of neutrons. So these type of question IMAT can ask. And then we have got electron configuration and energy levels. Electronic configuration is very important. So you need to know that how to find the electronic, how to do electronic configuration. So if you are given carbon atom and you need to find how many electrons are in p subshell of carbon. So how you can do this? We follow actually Aufbau principle, that is like 1s2, 2s2, and then school. I have make like mnemonics to remember easily, like school, public school, Dawn public school. So I have written in my notes, but I do not know what the trick to remember electronic configuration. Then in electronic configuration we have got Pauli exclusion principle and Hund's rule. Like Pauli exclusion, Hund rule say that there is a particular statement that all fall some I do not remember correctly, but there is like all 4 quantum numbers cannot be same for one particular shell or subshell. This was the Pauli exclusion principle. But then we have got Hund's rule. Hund rule say that Hund rules has like now I remember graphically that electron will be filled firstly one in each orbital, in each orbital, and then again one. So I cannot explain what are their wording, I do not remember that, but this is Hund rule. So next we have got atomic models. This is the history, Bohr models, and quantum theory. Quantum theory is very important. How you can like find you can find the angular momentum. You know what is the value of Planck's constant, and then what is the unit, how to like all the relations, all the relations. So the quantum theory is also important. So this is just a reminder that I have made biology class that is available on my channel. You can check that out. And then physics is coming soon. So this is our YouTube channel. If you like content, then do hit subscribe button. So now let's move on to so this is our biology class. This is the pretty thumbnail. Yeah, I'm at 2024 syllabus biology masterclass. I'm at exam syllabus. I just made I did some SEO to boost up. Hey, I did not share my channel at any group or anywhere except mine, but so that's why my channel is totally based on SEO, like search engine optimization. You search the query and my video will appear, because I do some technical stuff. I'm not flexing all that stuff. So but now let's move on to our periodic table. So this is the third chapter of inorganic chemistry, periodic table. Periodic table is very important. There will be like 1 or 2 questions done, 100% done from periodic table. So what periodic table is very easy, although this is very lengthy. This consumes so much time. I was like, at my time, I when I started my preparation, I started with periodic table, and then I ended my preparation with periodic table. So this is very important. Like it was like I was thinking that it will consume one day. I will finish this in 1 day or 2 days, but this periodic table thing consumed my 4 to 5 days. Now I'm going to explain how it was taking my 4 to 5 days. So first of all, periodicity and properties. We need to know periodicity and properties. What are the properties that you need to study? First of all, ionization energy. What is ionization energy? You need to know that. Ionization energy is the energy that is required to remove electron from the valence shell of gaseous atom. That is the ionization energy. First ionization energy is always less than second ionization energy. So these are the tricky points that you need to know. And then we have to know that in what unit we measure ionization energy. And then we need to know that what are the terms of ionization energy in periodic table, in periods, and then in group. We need to know that. Then we have got atomic radius. What is atomic radius? What are the units in which we may get atomic radius? Then what is covalent radius? And then what is van der Waals radius? Like covalent radius between two same atoms, non-polar. We are going to learn in chemical bonding what are covalent compounds. But for now, what is covalent covalent radius, and what is van der Waals radius and then we have got shielding effect. What is shielding effect? And what are the trends, periodicity? What are the trends in periodic table of shielding effect? Then we have electron affinity. What is electron affinity? What are the trends of electron affinity in periodic table? Always remember, first electron affinity is always negative, and the rest are positive. Like first is exothermic, is always exothermic, first electron affinity, and the rest are all endothermic. If I am correct, yeah, I have written my notes. I think if I added picture, let's see. And then electronegativity, and then there are in periodic table we have got 4 blocks: S, P, and then D in mid, and then F at bottom. I'm going to show you periodic table in a while. So in SP block, you need to know properties and trends. Properties, first of all, what you need to know that what are SP block, what are the elements included in SP block, and if you can remember, you should remember these. There are tricks like I have got tricks in my own national language. So if you know some tricks, you should learn that in your own language. That will help you to remember periodic table to solve maximum possible questions. So what is in S block element? You need to know the introduction to S block element. What are S block elements? So there are 2 S block. In S block elements we have got 2 rows. So first one is this is just S block, alkali metals, and then alkaline earth metals. So what is alkali metals? What are alkali metals? Properties and trends. You need to remember the trends. What is the trend of ionization energy from hydrogen till francium? And what is the trend of electron affinity? What is the trend of electronegativity from beryllium to radium? Always remember that ionization energy decreases from top to bottom in group and increases from left to right in period. The reason is simple. From moving from left to right, in IMAT 2023 there was a question from ionization energy. Like 5 elements were given with charge. Like they said that what is the element that has high ionization energy. So it was like from noble gases. I think neon was the right option. Yeah, neon was the right option. Yeah, they given like these lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then I think these 3 were not present, or fluorine was not. There was a question from this. You need to know that ionization energy decreases from right to left, and increases from right to left and decreases from top to bottom. The reason is simple. In group, the reason is because atomic radius increases from top to bottom. Shells increases, shell adds after every element, so that's why ionization energy decreases. But from left to right there is no increase in atomic radius, but there is increase of just nuclear charge. What is nuclear charge? Protons. What does proton do? Proton attracts electrons. So there is like attraction between protons and electrons, and in this case the nuclear hold on electron increases, and this becomes very hard to remove electron from valence shell. So this is how ionization energy increases. So the similar trend for all electronegativity, and similar trend for similar trend for shielding effect you need to study. Then we have got alkaline earth metals. So the basic question that are these both are basic compounds. So the question that can be asked from here, what alkali metals are more basic than alkaline earth metal, or alkaline earth metals are more basic than alkali metals, because these both forms ionic bond with the most electronegative elements. These are most electropositive elements because these are metals. From top to bottom excluding hydrogen. From lithium to francium, metallic character increases. From beryllium to radium, also metallic character increases. Also the reactivity increases from top to bottom. Very these will cause these will cause explosion if they are spread, or they are if they react with air, like if they are open placed naked, they will cause explosion. So these are very reactive. And then we have got here p block elements. What you need to remember in p block elements, first of all we need to know what is p block element. So from this was the s block element, this block s block, and from here to here this is p block. From group 13 to 18 this is our p block element. I just most of the people say this is group 3, this is 4, 5, 6, 7, 8, and they say that this is the 3 one. So there is no collapse, just go with 13 or 3, both are the same things. But then what these are the names of each family: boron family, carbon family, nitrogen, oxygen family, then we have halogens, and then we have noble gases. We also call these are also known as pinacogens, and these are also known as chalcogens, and these are also known as I do not know. These are, I think, chalcogens, and these are I do not remember, but whatever it is. So you need to remember the all those terms that we implemented on s block elements, on p block elements. You need to remember. So in p block element, I did not write the d and f block element. So let me explain what are the d and f block elements. These are the d block elements, and these are the f block elements. 2 series are f block elements, and these 4 series from here to here are d block element, transition element. These are known as transition element. Also these are also known as transition element. The f block series, f block is also known as transition elements, but the transition, they are known as transition elements. These are the outer transition elements, and these f block elements are the inner transition element. So you need to remember what are the basic properties, general properties of transition elements. What are transition elements? And then binding energy in transition elements, then alloy formation, diamagnetism, paramagnetism, and then we have got what is included in the NF block elements, some properties like what is vanadium used in vanadium pentaoxide is used in our contact process for preparation of SO3 from SO2 H2SO4 for making H2SO4, SO2 to SO3, and then SO3 to H2SO4, and then the uses of transition element. And there are a lot of mess and lot of detail. That's why I'm saying that this chapter took my 4 to 5 days to cover. These were the things that were very, 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 very informative, and to remember them you have to spend insane amount of time. So next we have got chemical bonding. This is our inorganic chemistry chapter. So in chemical bonding you need to know types of bonding. First of all, types of bonding. There are types of bonding is ionic, covalent, and metallic. I have explained in another way, intermolecular forces. I have added my notes pictures. Then you need to remember, you need to study hybridization. What is sp3 hybridization, what is sp2 hybridization, and sp. Example of sp3, example of sp2, sp. What how many pi electrons are available, how many pi bonds are formed, how many sigma bonds are being formed, what is the geometry of compound. We are going to cover in theories. We have got Vesper bond, VBT and Vesper theory. Yeah, these two theories we have got. So in bonding, you need to remember the ionic bonding, covalent bonding. Covalent bonding are of two types: polar covalent bond, non-polar covalent bond. Then we have got metallic bonding, coordinate covalent bond, hydrogen bonding, van der Waals forces, dipole interaction, London dispersion forces. So these are intermolecular forces. We are going to cover these up. Here we go. So this is the bonding. Let me explain what is the bonding. So intramolecular with an atom of molecules, and intermolecular is among molecule. So intermolecular is more stronger than intermolecular forces. Now, so the types were like intermolecular and then intermolecular. We have got the intermolecular are ionic bond, covalent bond, and metallic bond. But in intramolecular forces, we have got intermolecular forces between molecules. The intramolecular is between atoms within molecule. Molecule is composed up of atoms. You need to cover these basics too, like what is compound, what is substance, what is molecule, what is atom. So all that stuff. In intermolecular, we have got intermolecular forces. We have physical properties and types. So these are the types of intermolecular: ion dipole, dipole induced dipole. These are also known as Debye forces, London dispersion force, and hydrogen bonding. So I have explained each and every type with example, nature with example, with factors like ion dipole is between ion plus polar molecule. If ion and polar molecule are replaced here, their force, intermolecular force, will be ion dipole. So ion dipole force is directly proportional to polarity, and ion dipole is directly proportional to electronegativity. Inversely is directly proportional to charge over size ratio. So this is the examples. I have explained each and everything. Dipole and then induced dipole. You can like study here, pause this screen, and just if you want to study, go study it, or from the book that I shared, which you can study from there or from your high school book. Yeah, okay, that's all. Then we have got London dispersion forces. Some questions that some very informative and some very tricky points that I wrote here are these are given. Then we have got hydrogen bonding. So hydrogen bonding is important. Like this occurs between these three most electronegative elements, and then hydrogen, between hydrogen and most electronegative element. What are these most electronegative elements? Fluorine, oxygen, and nitrogen. So hydrogen bonding is extreme case of dipole forces. So this was the thing. And then this is the strength of intermolecular forces. Like ion dipole is more stronger than hydrogen bonding, and then dipole, and then London dispersion force. London force is the most weakest force. We also London dispersion force is also known as van der Waals forces. London dispersion force exists between all molecules, because this is, I have written here, it depends on electrons, so exist in all molecules. So I have written here. So next I have written like hydrogen bonding in H2O. We have got 2 hydrogen bonding. In HF hydrogen fluoride we have got 1, and then in NH3 ammonia we have got 1 hydrogen bond. Yeah, I think 1. This was just hidden. But anyway, so now next we have got, these are our intramolecular forces. Intramolecular forces are ionic, atomic. This is also known as covalent bonding. The molecular or London dispersion forces, van der Waals, and this is our metallic. So these are forces like in ionic bond, forces are ionic bond, in atomic they're covalent, van der Waals, metallic, and this is structure unit. In ionic bonding we have got ions, and in covalent bonding we have got atoms. Molecular we have got atoms and molecules, but in metallic bonding we have got atoms and free electron. Metallic bonding is you all have to know that this is the basic concept that a metal conduct electricity. Why? Because they have got free electrons, and metallic bond is due to free electron. Those free electrons, atoms and free electrons. So I have written each and everything is here, like what is the most hardest type of bonding, what is the most strongest type of bonding. So and then we have got some examples here, you can study these things. Now let's move on to our next thing, that is hybridization. So I have already explained, you need to know sp3, sp2, sp3, sp. I have included examples, all very detail of each and both these three cases on my notes. And then sigma bond, you can just study. I'm not promoting my notes, I'm not saying to you follow my notes. You can study from any book, and I would recommend you to prepare your own notes, so that in exam, at the time of exam, you can revise you can do multiple revisions of your notes, so that you will be like pro in your exam. So we have you need to know that what is sigma bond, what is pi bond, what is the strongest bond, what is the weakest bond in between these two bonds. Sigma bond is more stronger than pi bond, and sigma bond is head-to-head overlap, and pi bond is parallel overlap. You need to know these things in very detail, otherwise you cannot able to solve the tricky questions. So in theory we have got VBT and Vesper. Both these three explains the structure, geometry of orbitals. Hybridization is the modern form of VBT, valence bond theory. But then we have got examples. You need to like both these three, you have to know the examples of both three. For example, how many bonds are in specific molecules, lone pair and bond pair, how many lone pairs are in this molecule, in this you can judge those. I have like listed each and everything on my notes at the time of my study, so I will recommend you should do that thing too. And then in types, you need to know that what is this like how many, this is like, for example, I have written here two molecules with one bond pair, and the E1 means that it is lone pair, they have got one lone pair on it. So and then you need to know that what is the particular geometry of a molecule. For example, ammonia NH3 has got diagonal pyramidal, and water has got bent V shape, and then carbon dioxide has got a linear shape. You need to know each and everything. So then we have got acid and bases. In acid and bases, you need to first of all know that what are acid, bases, what is alkali. Water soluble base is called as alkali actually. So you need to know that these things in very detail. Then we have got definitions of acid and bases. What is the Arrhenius concept of acid and bases? What is the Bronsted-Lowry concept of acid and bases? What is the Lewis concept of acid and bases? You need to know that thing. Next we have got types of acid and bases: strong acid, weak acid, strong base, weak base. There was a question in 2023 from types of acid and bases. They given like 4 5 table rows. There was a table, and they said that what is the most strong bond. There were 2 questions from this thing, and if you would be like pro, you could have solved one question. If there were 2 questions from types of acid and bases, one question, if you solve one question, you can find the answer from that from one question of the second one. If you do not understand me, like there was 2 questions, one question was giving the answer of second question, second was giving the answer of first question. So I marked both of these correct. First I made mistake by solving the first question. I made it wrong, like I marked it wrong. But then when I went to the second question of acid and basis types, then I made the correction that I just made a mistake, that I did not mark the strong acid correctly. So I then went back and then I crossed it and then I put the right option, because you have got like one chance that you can, if you have got you can like change your option for one time. There is like the choice they have given. Then the most important thing you need to cover in acid base is buffer solution. What is the types of buffer and what are the examples of buffer? Now let's explain acid and bases in detail. Introduction to acid and bases, properties of acid, properties of bases, then Arrhenius theory of acid and bases, then Bronsted-Lowry theory, and then what is pH scale and indicators. There will be going to question from indicators, like what is like litmus paper, and then what is blue, what is red in litmus paper. So you need to know that red is, if it turns red, it is acid. If it turns blue, it is base, like strong. And you can differentiate that what is pH scale. So I have drawn the pH scale here. So 1 to 6 it is acidic and 7 is neutral. Water has got 7 pH, and then above the higher the pH, it means the solution is basic. So we got a problem that we demonstrate pH with acidic nature, like higher the pH, higher will be acidity. But that's not true. The lower the pH value, the more acidic will be solution, and the more higher the pH value, the more basic the solution will be. Then we have got stoichiometry. Stoichiometry is very, very important. I'm going to explain in very detail stoichiometry, because I have added tons of notes here. So in stoichiometry is important, that because maximum two questions. Each year he's going to ask you two questions, at least two questions, because many questions, many problems, many problem-based question can arise from stoichiometry. Now let's see how it can rise. So first of all, in stoichiometry you need to cover atomic mass. What is the atomic mass? You need to actually remember the atomic masses of maximum elements in periodic table. The periodic table is not allowed in IMAT exam, but sometimes they give the values, actually the numbers, but sometimes they do not, they don't give. So the best way is you should remember. These are easy to remember. For example, hydrogen has got 1, then carbon has got 12, and then actually hydrogen has got 2 atomic mass, atomic number is 1. Then carbon has got 16 atomic mass, and carbon has got 12 atomic mass and 6 is atomic number. Oxygen has got 16 atomic mass and 8 atomic number. Then the most important, like nitrogen has got 14 atomic mass and 7 atomic number. Like and then we have got like lithium 3. There are like huge. I at my time I remember maximum. I have solved multiple times. I practiced this chapter multiple times at my time. So then you can find molecular mass. How to find molecular mass? So if they give you a molecule like C6H12O6, you find molecular mass of it? If yes, then you are legend. If you cannot solve, then you are broke. Then we have got formula mass. What is formula mass? You need to know that. Then we have got mole. What is mole? Mole is very, very important in stoichiometry. You need to remember the units of mole. What are the units of mole, and how to find actually moles? This is very tricky, and this is the thing from where IMAT examiner is going to make questions. and then we need to know what is limited reagent and what is excess reagent. And then stoichiometry is applied here, mole to mole calculation, then mole to mass calculation, and then mass to mass calculation, mass to mole calculation, mole to volume calculation, and volume to mole calculation. I did not write here mole to volume, but you do need to remember this thing. And then in last we have got yield. What is actual yield, theoretical yield, percentage. So multiple times examiner has question for percentage yield, so you need to remember the formula how to find percentage yield. This is a procedure, you need to learn that. So in stoichiometry we have got this thing like atomic mass. I have explained what is atomic mass, why we have got why we take C12 as our standard, and why we do not take hydrogen as our standard. So this is the thing that I did not that I mentioned in my notes, so I made some questions. And then we have got average atomic mass. So this is the most important thing, mole. What is mole? Mole is the counting unit, representation is n, and symbol is mole. So when atomic mass, molecular mass, or ionic mass expresses in gram, it is called as mole. So this is the definition of mole. When atomic mass or I'm using or molecular mass or ionic mass is expressed in grams, it is known as mole. So 1 H2O is equal to 18 AMU. This is the AMU is the unit of it is relative atomic mass and gram. So it means 6.023 multiplied by 10 power 23 H2O molecules equal to 18 gram is molar mass. Molar mass, it is like we are this is the molecule, and if it would be like here are 6.023 10 power 23 molecules, that's why we are using gram. If it would be like 1 H2O, then here would be molecular mass, and that would not be 18 gram, so it would be 18 AMU. Yeah, that would be relative molecular mass. Yeah, I have written actually here 1 H2O. This is the relative atomic. I have written this is known as relative atomic mass, but H2O is actually molecule, not atom. So this is common sense. And then I have written the other names of mole. What it is also known as gram atom. It is also known as gram molecule. It is also known as gram ion. And then gram formula unit. These are the other names of mole. And 20 gram atom of hydrogen is mole, but 20 gram of hydrogen atom is given mass. So here are the formulas that I have written, like a number of moles is equal to mass over molar mass. This is the highly used formula that you are going that you will use in maximum problems. I was just I did not use this in my exam preparation, because I'm at exam preparation, but in my high school I was using it very frequently, because in my exam preparation I just learned the shortcuts, tricks, like how to solve by just looking at equations, just halving the moles and getting on other side. If it were like given on a reactant side, moles were given, but we need to find on product side. So I was just like make it half or make it double, all the stuff. So I'm going to just explain you in a little bit. Then this is the another formula of moles. Number of molecules divided by Avogadro's number is another formula for mole. Then the other formula is volume over molar volume. So number of moles is directly proportional to number of atoms or number of molecules, and number of moles is directly proportional to volume. So next we have got another thing, that is molar volume. So volume of 1 mole of any gas at STP is molar volume. What is molar volume at STP? 22.414 decimeter cube or 22.414 centimeter cube. At RTP it is 24 decimeter cube. Okay, 1 mole of CH4 is equal to 6. This is the equation that I was talking about. So if you remember this, so for example 1 mole of CH4 is equal to 16 gram. This is the molar mass. 12 is the atomic mass of carbon, and then add 4 of hydrogen. 3 is 12 and 4 hydrogen equal to 12 plus 4 equal to 16 gram. So this is molar mass, and 1 CH4 is equal to 6 multiplied by 10 raised power 23 molecules of 1 mole is equal to 6 multiplied by 10 raised power 23 molecules, and this is equal to 22.414 decimeter. So if you learn this, you can easily solve this. So these are all the calculations. For example, how many molecules of O2 are present in 2 moles? How many molecules of O2 are present in 2 moles? In 1 mole, it is equal to how many molecules of O2 are present in 2 moles? In 1 mole, 6 multiplied by 10 raised power 23. In 2 moles, 12 multiplied by 10 raised power 23. Just multiply that thing with 2. So 12 multiplied by 10 is, I have written 1 mole is equal to 6 and 2 moles is equal to 12. So this is the right option. And these are all the questions that are from these equations. If you like to follow my way, you can. And these are also the equations, and then this is the examples that I made. This is very easy, very easy to do. So this is these are all the questions that I made, like how many electrons and protons and neutrons are present in 9 gram of ice. I use this is the formula. Number of electrons or protons equal to a mole multiplied by Avogadro's number multiplied by atomic number. What is the atomic number? Atomic number is Z. You need to find you need to remember atomic number. So this is how you can find. And then this is the another equations that I was talking about. I was not using formulas, I was using these equations. By using these equations, I was solving stoichiometry problem, and I was very good at solving these. In my high school, I was not very good, but in my exam, I was very sharp in solving these things, because I practice. Only thing that can make you best at everything, that is only practice. So practice as much as you can. Then this is the stoichiometry. So I have written stoi. The question spellings are good. Okay, relative amount of reactant and product in balance equation. So what we do is we balance equation to equalize only atoms and mass. So this can be asked. So I have made examples here. The stoichiometric calculations. So these are some stoichiometric calculations. So how we can do stoichiometric calculations? So let's see this. All reactants must be converted into products. So these are the assumptions. For stoichiometric calculations, our reactor must be converted into products, no side reaction, so that our product cannot be wasted. A law of conservation of mass, law of definite proportion. So these are the things that you need to know. So this is the drawback of balanced chemical equation, and then these are the calculations mole to mole. So I have written the one example of mole to mole. If moles are given, then calculate the moles on other side. So this is how I was just using equations. I was not. This is very easy. I can just explain, and the time is running very fast. It is 38 minutes now, so I cannot explain each and everything. I'm just trying to make it 1 hour lengthy class. So this is how you can actually I know that you will know that how to solve that. You are not kids, you are appearing in IMAT exam, so you will know more than me. Why I'm pretending that I know each and everything. And I know that you are a very good student. So then we have got mole to volume example, and then more mass to mass example. Next we have got limiting reactant. What is limiting reactant and how to find limiting reactant? So this is the formula on other page. Yeah. So what is limiting reagent? That consumes earlier in reaction, that is limiting reactant. And so this is the example. Which of the following is limiting reactant in H2O? So the in balanced chemical equation there is no limiting reactant, but this is assumption. So this is the formula of calculating limiting reactant. Mole of element divided by coefficient on balance equation. So just find mole by that using that formula. N is equal to mass in gram divided by molar volume. Molar mass. Just use that formula, calculate mole of element whatever the element is given, then this is the coefficient. Just divide this with, you will get element reacted. So I made some I have written 3 examples here, 1 2 3, and the procedures to solve all the stuff. If you want to look, you can pause the screen and look, you can watch, you can read this thing. And then this is the mole, this is the excess reagent. This is also the example of this limiting reagent. So I have used this excess reagent, mole of excess reagent used to compare reactants. I have did not, I will say the majority of the questions are from limiting reagent. No, they do not ask from excess reagent. So that's why the limiting reagent was in detail, and there is no such detail of such reagent in our high school books. If you are studying from Pearson, you will find out. And then we have got yield. The most important topic is here. So this is the formula that you need to remember. This is just dumb, but you should know that actual yield is always less than theoretical yield. Why? Because reversibility of reaction, side product conditions does not remain stable, and then inexperience of person, mechanical loss, all that stuff. But this is the most important formula. Percentage yield is directly proportional to percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. So this is how you can find percentage yield. I have added 2 or 3 examples here. You can look at that. I'm not going to explain, but now let's move on to next slide. That is my handwritten notes. So if you are loving my notes, you can surely go to this video. I have uploaded this video 3 months ago. 3 months ago. You can see that, and I have explained how you can download the PDF for absolutely free, no money at all. No money. I will never charge you for anything unless I'm putting very huge effort. The notes was like I was preparing, and that was my need. I prepared it and I happily share with you, so that you, if you want to read, you can just go through it. If you want to download, just go to this website, samiqamar.com. I recently bought this domain. You go to samiqamar.com and search IMAT notes. You will get there, or check the video description. This video description or the video that I mentioned previously, you will find a link to download those notes. Or just go to Google and search Sami Qamar IMAT notes. IMAT handwritten notes, IMAT notes, whatever you search, you will get that. Sami Qamar handwritten notes. Yeah. Solutions and solvents. So this is another important 1 question or 2 questions from each. Either you will get from psychometry or solutions and solvents. So these are 2 main chapters from where you are going to get question, either from psychometry or either from solution, or that can happen like 2 questions from solution and solvents and none from psychometry. 2 from stoichiometry and none from solutions and solvents, but that can happen like 1 from solution and solvents and 1 from stoichiometry. So let's see what you need to cover in solutions and solvents. So first of all, what is solution? Their types, homo and hetero solution. Solvent, what is solvent and what is solute? And then these 2 terms are very important, molarity and molality. These are the things. These are the 2 terms from where questions are going to made, like stoichiometry. For example, you need to find mole per liter. These are the calculations. Actually, this is the formula of molarity. It is also known as concentration. Concentration is number of moles. Yeah, that is concentration. Then the main important thing that I did not write here is KSP. That is like a solubility product. That was also given in our syllabus. Solubility product, how to find KSP. There is like formula. Chemistry is like little bit bad for many students, like there are formulas, calculations. The organic chemistry that is going to just like appear in a few minutes, most students fear from that. That is very interesting. I just found it interesting. Like when you are understanding something getting into your mind, you are enjoying it. You like, if you practice it, you will enjoy it, but if you are not getting it, then that's a very problem that gets hectic. So in solutions, you need to do introduction and then key points. What are the key points, solvent and solutes? molarity and molality, you need to understand characteristics and properties of solutions, factor affecting solubility, solution preparation and dilution techniques. You just forget this. So saturation, supersaturation and unsaturated solutions are important. These are important terms, the important types. Just study them and remember the examples. So if here you go. Then this is the formula that I was talking about. Polarity formula is moles of solute divided by solution, liters of solution, mole per liter is. You are going to ask the question. Examiner is going to ask questions from this formula. So this is the formula. I was very bad at this formula. I practiced multiple times in my last till my last day of exam preparation. I was solving this. I was just getting this question. I was like fearing from decimeter cube and liter. These two terms were fearing me because I did not learn them in these two solutions chapter in a very good way in my high school. That's why I was getting very problem in my exam preparations, because I was solving in a formal way by using formula, but I was not good at equations for a solution and solvent chapter. So I was getting very hectic. That was very hectic for me. So I just practiced it, and I did get mastery on this solution, how to solve this by equation. I was this was consuming time. Formula was consuming time, putting each and everything in formula. And if you put the questions are if you solve question, soon I will share some questions. If you solve questions from either BMAT or IMAT, you will see that the questions, if you use formula, the question will get lengthy. The 1 minute question will take your 10 to 15 minutes. So that's very bad. So that was my problem I was fearing. And then if you are enjoying this video, then do subscribe. So this is my Instagram handle. Just subscribe it. I will not I do not like saying that subscribe, but do it. It will be good sport for me. That's so far we have got 508. No, this is very we have got some 550 subscribers right now. So just that's if I get subscribers, that's motivation. That's a little bit motivation, and I make videos. So just subscribe it. That's motivation for me, and I would enjoy at making the video. So now let's move on to another chemistry inorganic chapter, that is chemical equilibrium. So in equilibrium we have got to cover we need to actually cover what is equilibrium, what is reversible reaction, what is irreversible reaction, what types of equilibrium, forward and backward reaction. Then the most important topic is law of mass action. What are the conditions, what is speed of reaction. So we need to actually know that. We are going to actually speed of reaction, we are cover speed of actually I had to extent of reaction, how much reaction is completed in forward or backward direction. And the most important type that is included in chemical equilibrium is Le Chatelier principle. So we need to just cover that thing. So this is the some my notes, what is equilibrium, and some I have written some definitions, and then we have got characteristics of equilibrium. And next we have got types of chemical equilibrium. So here are the types: homogeneous and heterogeneous equilibrium. What is homogeneous? If it is same phase like solid making solid, that is homogeneous, and if it's some different solid making liquid, then it is heterogeneous. So this is law of mass action. It is derivative concentration of reactant. The law of mass action is very important, so you should master that. And I have explained very detailed terms. So now actually my storage is getting low on my camera, so I'm just getting hurry up this class. I will just show you what you need to cover in each chapter. So then this is the some units, how you can write law of mass action if it is given. This is what is the basic way, product over reactant. So C and D will be above and A and B will be below. So I have written some tricky points here. And then this is the characteristic of chemical equilibrium. Kc is chemical equilibrium constant. Then units of Kc. How you can find units of Kc? Then we have got a relation between Kp and Kc. Pressure constant, equilibrium at constant pressure, and Kc is the general reaction equilibrium constant. Then we have what applications of Kc, extent of reaction. This I was talking about this. If Kc is very large, it means that reaction almost completed. In formal reaction, if it is very small, -30, 10 to the power -30, it is reaction is just started, and it is neither small nor large, 100. Then it means reaction is at equilibrium. So then we have got direction of reaction. So what is the direction of reaction? Either it is forward, it is backward. And then we have got Le-Chatelier's principle. Le-Chatelier's principle is all about if stress is applied on reaction at equilibrium, then it will go either in forward or backward. This is all about Le-Chatelier's principle. I did not added my whole notes. First, it has got effect of concentration, effect of pressure, then effect of volume, then effect of temperature. Kc, always remember, Kc is only affected by temperature, nothing other effects, not volume, not pressure, not concentration affects Kc. It only changes Qc, that is the concentration taking. I have written here something somewhere. Yeah, this is it is the just ratio of it is the just ratio and concentration taken at any time, if it is taken at any time. But Kc is achieved at specific time when forward reaction becomes equal to backward reaction. Then we have got chemical kinetics. This is very important. You need to know the rate. What is rate law? What is the order of reaction? The types of order. First order reaction, either it is first order reaction, it is second order reaction, either it is third order reaction. And this is also important. Factors of affecting rate. My question mark is just get buffed into my rate. That's funny. That's not funny. Factors affecting rate. What are the factors that are affecting rate? And then we have got finally we have got activation energy. So I have added some of my notes. What is chemical kinetics, types of reaction, rate, and then rate law, rate equation, rate expression. I can actually explain each and everything you right now in very detail. You will be just amazed. I can literally spend hour explaining just these 2 pages, but just I can I'm just trying to make this class very short. So I am just trying to not make so much lengthy class. So just if you want to read, just pause the screen and you can read it. This is very valuable. I know that these points are very important. I have just written, so you can check that out. Next, these are the order of reaction, how you can find order, activation energy. So then this is the rate, this is the activation energy. This is the exothermic for exothermic reaction, for endothermic reaction. So I have added a very detail. If I sit explaining, it will take ages. So then we have got the last chapter of inorganic chemistry that is included in IMAT syllabus, that is electrochemistry. And in electrochemistry, we need to know that what is oxidation, what is reduction, what is oxidizing agent, what is reducing agent. Actually, you need to actually find. You will be given in IMAT exam. You will be given equation. And they will ask you in this equation, for example, Cl, chlorine, or NO3, what is, either it is oxidizing agent, reducing agent. So there will be a question. And the most important thing, that is balancing equation. Balancing equation is very important. One question can be asked, and I can bet that there will be at least one question every year. I think this in 2023 there was not question from the balancing equation, but every year, if you explore questions of either papers of BMAT or IMAT, you will get one question, at least one question in every year. So electrochemistry, I have added like what is oxidation number and what is oxidation, what is reduction. So if it is addition of oxygen, it is oxidation. If it is the removal of oxygen, it is reduction. If it is the removal of hydrogen, it is the oxidation. If it is the addition of hydrogen, then it is reduction. So I have added the most important point is of electrons. In terms of the most important definition is in terms of electrons. So loss of electrons is oxidation and gain of electrons is reduction. This is only how you can find reducing agent or oxidizing agent in balanced chemical equation. So I have added the example here. For example, if anything is solo or when it is in atomic form atomic form and molecular form, the atomic number or oxidation number is always 0 in equation. So here it is in atomic form, it is 0. Here chlorine is in its molecular form, oxidation number is 0. But here we seen that plus from 0 to plus 1 it is increased, oxidation increased, but from Cl to 0 to minus 1, so it means its oxidation number decreased. Na0 here, but Na plus 1, it means that it lost its one electron, so it is increase in oxidation number. It means that from plus 2 to plus 3, it means that one electron is lost. So this is oxidation. When it is oxidation, it means that substance is acting reducing agent. So I hope you would have get that my point. So if it means here the basic thing that is happening is Na is losing electron. When it is losing, that's why plus 1 is 0 to plus 1 is happening. Increase in oxidation number is oxidation, and the substance that is doing oxidation is reducing agent. That is the basic definition. If you remember, I have made my concept like this. You can make your concept likewise. Then here are the rules of oxidation. For example, this is how you can remember oxidation number. For example, oxygen has got -2 oxidation, and then halogens has got -1 oxidation number or -7. It can be ranges. It ranges from -1 to +7. -1 +1 +3. Here fluorine has chlorine has -1. Here +1. So it depends on condition. So if you remember the oxidation number of hydrogen, it is +1, and oxidation for oxygen it is -2. You can easily find the oxidation number of other elements easily, atoms other easily. So these are some rules. For example, I was saying solo state, it is free state. When it is in free state, its oxidation number is 0. Homoatomic or in molecular form, it is in homoatomic molecular form. S8, for example, sulfur S8, chlorine Cl2, hydrogen H2, oxygen O2. It means that their oxidation number is 0. Okay, these were the rules. And then we have got our second. That was all our inorganic chemistry. Now we have got organic chemistry. I have made very short. I like made my notes. I have added one PDF of my notes that contains all chapters of organic chemistry. So for example, I have made like in organic chemistry, you can I explained earlier that introduction, that hydrocarbons, alcohol, phenols, aldehyde, ketones, carboxylic acid has got its derivatives, and then we have got alkyl halide. In organic compound, in introduction, you need to know that what is organic chemistry, definition and importance, functional group and homologous series, and the structures, alicyclic, either it is alicyclic. We are going to actually deal with those things in the hydrocarbons. So these were the basic things you need to know in organic compound. So after organic compound, we have got hydrocarbons. Hydrocarbon is very important. Hydrocarbons have got alkenes, alkynes and alkanes. Alkanes and alkynes. Alkanes are single bonded, alkenes are double bonded, and alkynes are triple bonded. So you need to actually remember that how you can, like, you will be, there will be not easy questions. For example, this is if it is contains a single bond, it is alkane. No, that is not going to happen. So you will get very, very tricky questions. You will actually need to remember the basic formulas For example, it will give you like a bigger value. For example, here I have written C2H4. The ethene, it is ethene, carbon with 2, but they will give you carbon with 10, carbon 10 or carbon 14, 15. So that will be like higher, and they will ask you either it is alkene, alkyne, and all this stuff. So if you will get confused at the exam time. So if you remember formula correctly, you will be like you will easily solve this that type of question. Then we have got so in alkenes, alkynes and alkynes, what you need to know, first of all, you have to know the basic nomenclature. What is the naming, how you can name, common naming and IUPAC naming is very easy. Common naming is little bit difficult there. You need to remember a lot of name. IUPAC naming is why it is easy, that if you learn the rules, if you like master the rules, you can solve all of the organic chemistry easily. So then we have got isomerism. So then you can like then we have got isomerism. In isomerism we have got structural isomerism and stereo. This is not stereo, this is stereoisomerism. I'm not talking about why stereo, and if it would be stereo, sorry, it's stereoisomerism. And then structural isomerism, I have taken very awesome notes of isomerism. Yeah, you will be easily understand those notes, because I have like on one page there is like small whole 1 page 2 page of isomerism. Then we have got benzene. In benzene you need to know the nomenclature, properties, preparation and reaction. Similarly, in alkanes, alkenes, alkynes, you need to know the basic properties and what is the preparation of alkane or alkyne. For example, alkane, what are the reactions that alkenes follows, what alkyne follows, alkane follows. For example, alkane follows what is this? Free radical substitution reaction. Yeah, free radical substitution reactions are followed by alkanes, and alkenes follow addition reactions. Alkane follows addition reaction, because they have substitution and addition reactions are both possible, because they have got double they have got double and triple bonds, and then those bonds will be broken and something will be added. That's why this is addition. So you actually also need to know the elimination. What is the difference between elimination reaction and substitution reaction? Elimination result in the double bond formation, and substitution will result in constant, no bond change will occur. So in benzene you need to know nomenclature of benzene. For example, the special type of benzene, what is nitrobenzene, what is sulfobenzene, how to prepare benzene, what type of reactions benzene undergoes. For example, the majority, the best reactions or the most followed reactions of benzene are electrophilic substitution reactions. So these are the reactions that you need to know in terms of benzene: Friedel-Crafts acylation, Friedel-Crafts alkylation, sulfonation, nitration. So you need to know all those stuff. And then for other functional groups, for example, alcohols, phenols, ethers, amine, aldehydes, ketone, carboxylic acid, esters, amide, you need to follow this thing. What this thing is, you need to first of all you need to know the nomenclature. Then you need to know the properties. What are the basic properties? If you also I know that properties take ages to learn, or like you cannot remember all those properties, but if you will study frequently, you will master this thing. But in alcohol, phenols, or all these functional groups, you also need to the most important things are preparation and then reaction. Most important thing is preparation and reactions. So what is the preparation of a specific thing, and what type of reaction that thing undergoes? For example, if it's alcohol or phenol, what type of reaction this undergoes? Although all the reactions and preparation I am saying again that I have made my notes of organic chemistry in one PDF file that contains all of the these alcohols, ethyramines, of all the functional group reactions, preparation and IUPAC names. Yeah. this is very easy. So if I say that most of the students get very like stuck, that they have got mind that we organic chemistry is very strong, very hard, we cannot do it. This is not hard. If you are practicing daily and you are understanding and then practicing, then I can bet you that this will going to be far more easier than you are expecting. This is not easy. I know that this is lengthy and tricky and needs like focus and energy, but this is interesting. So if you have learned this from high school, then you are going to master it easily and you will enjoy doing it. So this in carboxylic acid, we have got some addition that carboxylic acid has got its derivatives. You need to cover those up too. For example, esters, and then acid anhydride, acid amide. So you need to cover all those up. And the most important thing that you need to know is a functional group. The functional group you should master. You should remember all the functional groups. For example, what is the functional group of amide? You remember that this is double bond NH2. What is the functional group of aldehydes? C double bond O, alkyl group. This is how you need to quickly master all these things. So this was our organic chemistry. I haven't explained organic chemistry in very detail. Like I could have explained, that would be like 2-3 hours lengthy class, that about how to prepare alkenes, how to prepare alkynes, how to prepare alcohols, phenols, all that stuff. You need to remember that reduction of alcohols and phenols will form what, and oxidation of aldehyde and ketone will form what. So these are opposite things, and this will just be like a question can be asked from the thing. So this was all our chemistry class. I know that I haven't explained each and everything. Sorry, I was trying to explain IMAT syllabus. I was not like doing lecture. I have explained syllabus, each and everything in ES syllabus, but I haven't like given lecture. I have explained my notes, like what is KSP, what is alkyl halide, how to prepare alkyl halide, what are the conditions, what is primary alkyl halide. I cannot explain that this will make more lengthy, but hopefully you would have enjoyed that. So if you want to ask anything, you can just directly go to @isamikamar on Instagram. So if you want to anything, just go to this Instagram handle isamikamar, or so this is my website samikamar.com. Here you will get exclusive content soon, like BMAT question papers, past question papers, past IMAT question papers with complete solutions, and IMAT ranking, all the stuff. That will be not for all that IMAT, that would be like personal blog stuff, but you will get actually maximum resources there. And my earlier domain was just going to expire, so I thought now let's buy our high TLD domain. So we have bought this, and you will enjoy the content actually. And then so that was for all today. If you have enjoyed this video, then hit like button, and just go and watch our biology class if you haven't watched, and just wait for, then if you have watched it already, then wait for our physics masterclass, IMAT masterclass. And so thank you for watching, and see you in next video. Till bye bye.